Hi everyone. As you remember from our previous lecture, we talked about first order low pass filter. Today I want to talk about active first order high pass filter. So I'm going to show you how the circuit looks like and also how we can analyze the circuit and see what is the transfer function of the circuit. In order to have a high pass filter, what we need to have is an op-amp circuit in which the input impedance is combination of a resistor and capacitor in series. So I have R1 and 1 over CS as my input impedance. And then my feedback impedance is going to be a single resistor. So what I have here is my feedback impedance. And now in this circuit, I'm measuring my output signal to be the VO, which is the output voltage of the op-amp. And remember that the positive terminal needs to be grounded, and my input will be applied to the negative terminal of the op-amp. So here is my VI, and here is my VO. Now let's look at the transfer function of this circuit. In my transfer function, I'm looking for VO over VI. And we know that whenever we have an inverting amplifier, the amplification ratio is going to be minus ZF over ZI. ZF is the feedback impedance and ZI is the input impedance. So it means that my VO over VI is minus feedback impedance, which is just R2, and then over input impedance, which is R1 plus 1 over CS. So what I'm going to do is that I will multiply both numerator and denominator by S, just to get rid of S here. So I will have minus SR2 over SR1 plus 1 over C, and then I will divide everything by the coefficient of S in denominator, which is R1. So I will multiply everything by, in both numerator and denominator, by 1 over R1. So my transfer function will be minus R2 over R1 multiplied by S divided by S plus 1 over R1C. As you can see, this transfer function is a transfer function of high pass filter because I have first order polynomial in denominator and in numerator I have S. If it was a constant, then it would be the transfer function of a low pass filter, but because I have S, then it's going to be the transfer function of a high pass filter. And in this high pass filter, 1 over R1C is my cutoff frequency, and the coefficient of S in numerator, which is this one, is going to be the gain. So here, as you can see, this is a high pass filter in which the gain of this circuit is equal to minus R2 over R1, and omega C is equal to 1 over R1C.